So students, let us continue the chapter. So progressions. There are two types of progressions which you will be studying in this chapter. There are more, but you will be only studying two types of progressions, and those are arithmetic progressions and geometric progressions. So let us look what they are. Arithmetic progressions. These are few examples of arithmetic progressions: 1, 4, 7, 10, 13, 16, blah blah blah, and 0, 2, 4, 6, 8, 10. But what is the specialty of these progressions? If you look at an arithmetic progression or any type of arithmetic progression, you will see that there is a common difference between each term. See, 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 3 is 16, plus 3 19, plus 3 22, plus 3 25. Keeps going on like that. And the same thing, there's another example: 0 plus 2, 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 2, 10, and so on. So what do you see? You see that there is a common difference between each term of a progression. And when there is such a case, or when there is such a pattern, when there is a common difference between each term, then that progression is called an arithmetic progression. Now this is the first progression that we came across, the Fibonacci series or sequence. In the Fibonacci sequence, is this an arithmetic progression? Let us check. 0 plus 1 is 1. Okay, 1 plus 0. There itself it is gone. But anyways, let us keep looking. 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13. No, it is gone. It is gone. There is no common difference. So therefore, Fibonacci sequence is not an arithmetic sequence, or it is not part of an arithmetic progression, because there is no common difference. Do you see that? Now let us generalize these things, let us bring it up into a formula. So suppose my first term is a1, second term a2, third term is a3, fourth term is a4, fifth term is a5, and so on. And suppose I am taking n terms. So if I am taking n terms, then the nth term will be an. Okay. Now the arithmetic progression, as I said, it is based on a common difference. So a2, I can write it as a1 plus d. D is the common difference. Okay. So if d is the common difference, I can write a2 as a1 plus d. Then the next term a3, I can write it as a2 plus d, the previous term plus d. a4, I can write it as a3 plus d, the previous term plus d. a5, I can write it as a4 plus d. And an, I can write it as an minus 1 plus d. That is the n minus 1, the previous term before nth term, the previous term plus d. Now suppose my first term is a, that is the value of my first term, and so what will be a1 plus d? It will be a1 is a, so a1 plus d is a plus d. Next, a2 plus d. What is a2? a2 is the second term. This is the second term. Second term is a plus d. So a plus d plus d. Right. So that is a plus 2d. Then what about the next thing? a3 plus d. a3 is a plus 2d. So a plus 2d plus d. That is a plus 3d. Then a4 plus d is a plus 4d. And so on, it keeps going on till the last term an is an minus 1 plus d. And when I'm writing it like this, it will be a plus n minus 1d. Did you understand how it came? Look again. The second term, let me take it back again. The first term, second term is a plus 1d or a plus d. Third term is a plus 2d. Third term is a plus 2d. Fourth term is a plus 3d. Fifth term is a plus 4d. So you see, second term is 1d, third term 2d, fourth term 3d, fifth term 4d. So it is 1 minus every time, right? Fifth term is 5 minus 1 4d, fourth term 4 minus 1 3d, third term 3 minus 1 2d, second term 2 minus 1 1d, and first term 1 minus 1 0. So there is no d. So you get it. So last term will be a plus n minus 1d, n minus 1d. Okay, so with this in mind, we can see that this is the general form of an arithmetic progression. Now arithmetic progression is a big word so we use a short form, and the short form is AP, and it is an official short form. Okay, so whenever you see in this chapter, or whenever I use the word AP in this chapter, it will be arithmetic progression. Now a plus n minus 1d, this is the, and a I can write it as a1 because it's the first term, right? Now this is the nth term, right? So this is a formula with which you can calculate any term in the arithmetic progression. So if you know the first term a1, and if you know the difference d, then if you want to find the fourth term, substitute n is equal to 4. If you want to find the fifth term, substitute n is equal to 5. If you want to find the 100th term, just substitute n is equal to 100. So you see the beauty of having a formula. So this is it for this video. In the next video, we will see on how to add all these things up. Okay, so see you in the next video.